Hello everyone, I am Mangesh Kukre, a second year student pursuing a Bachelor of Data Science in Christ University, Lavasa. Today I am excited to delve into world of NoSQL database and explore the difference between two prominent players in this field, Apache Cassandra and MongoDB. Now comparing Apache Cassandra and MongoDB, exploring two popular NoSQL databases. Apache Cassandra is distributed, decentralized, fault-tolerant system, and MongoDB is document-oriented database, scalable and flexible. Now talk with data model and schema flexibility. Apache Cassandra follows a column-oriented data model with fixed schema, suitable for write heavy applications and time series data, where MongoDB uses a document-oriented data model with dynamic schemas ideal for applications with involving data structures and complex queries. Now just talk about scalability and performance. In Apache Cassandra built for linear scalability and high performance read and write operations, making it preferred choice for large scale distributed systems, where MongoDB is scalable but with a focus on easy of use and developer productivity, making a suitable for smaller to medium sized applications. Now let's talk about consistency and availability. In Apache Cassandra offers tunable consistency level with eventual consistency by default, ensuring high availability and fault tolerance, wherein MongoDB supports strong consistency with options for eventual consistency, providing flexible based on application requirements. Now querying capabilities. In Apache Cassandra optimized for fast writes and scalable data storage, supporting limited query capabilities with SQL Cassandra query language, while MongoDB provides rich querying capabilities including ADO-HOC queries, aggregation pipelines, and secondary indexes, making it versatile for diverse use cases. Now use cases and industry adoptions. In Apache Cassandra, commonly used in applications requiring high availability, real-time analytics, and distributed data storage such as IoT, financial services, and social media platforms, where MongoDB widely adopted in web and mobile applications, content management systems, and data-driven from variable, flexible, scalability, and ease of development paramount. Now comparing scalability approaches of Apache Cassandra and MongoDB. Both Apache Cassandra and MongoDB offer scalable approaches, but they differ in implementation and management. Apache Cassandra's decentralized architecture and atomic partitioning make it well suited for massive scale and high availability scenarios. MongoDB's shared sharding capabilities provide flexibility in data distribution and performance optimization, catering to growing data volumes and diverse use cases. Now comparing consistency and availability in Apache Cassandra and MongoDB. Consistency models. Apache Cassandra offers tunable consistency level ranging from strong consistency to eventual consistency. Its default consistency level is eventual consistency, ensuring high availability and low latency for read and write operations. It supports quorum, local quorum, each quorum, and all consistency levels to fine-grained control over consistency versus performance. MongoDB supports strong consistency by default, ensuring that read operations reflect the latest write within a replica set. It provides options for eventual consistency through read preferences, allowing applications to prioritize consistency or availability based on requirements. Offers read preference like primary preferred, secondary preferred, nearest for configuring consistency levels. Let's compare the performance of Apache Cassandra versus MongoDB. Write performance. Apache Cassandra optimized for high speed writes, especially in write heavy workloads, It uses log structure storage engine and distributed commit log for efficient write operations. Its write operations are asynchronous and batch, reducing latency and improving throughput for insets and updates. In MongoDB offers good performance but may experience higher latency in write-heavy scenarios compared to Apache Cassandra. It uses memory-mapped files and write-ahead logging for durability and recovery impacting write throughout under heavy load. Now read performance. In Apache Cassandra, its read performance is optimized for linear scalability, especially in large distributed clusters. It supports tunable consistency levels, allowing for faster read operations at the cost of consistency guarantees. In secondary indexes and materialized views can improve read performance for specific queries, while MongoDB provides fast read operations, especially in scenarios with well-indexed queries and smaller datasets. It utilizes caching mechanisms like wire triggers, cache, and MongoDB's in-memory storage engine for improved read performance. Its aggregations, pipelines, and secondary indexes enhance query optimization and retrieval speed. Now let's compare the use cases of Apache Cassandra and MongoDB. Apache Cassandra excels in use cases requiring high availability, real-time analysis, and scalable data storage, particularly in distributed environments with massive data volumes and write-intensive workloads. While MongoDB is well suited for applications with flexible data structures, complex queries needs, and transactional requirements, catering to content management, user profiles, and transactional systems. Let's compare the community support of both. Now, community support of Apache Cassandra has a strong and active open source community with contributors from various organizations and industries. Community driven forums, mailing lists, and online resources providing extensive support for developers, administrators, and users. Regular meetups, conferences, and workshops facilitate knowledge sharing and collaboration within the Cassandra community. While MongoDB boasts a large and vibrant community of developers, database administrators, and organized globally, offers comprehensive documentations, tutorials, and forums to assist users at all levels from beginners to experienced professionals. MongoDB University provides free online courses, certifications, and training programs to enhance skill and promote community engagement. Now let's compare the security comparison features. In Apache Cassandra and MongoDB offers robust security features including authentication, encryption, editing, and monitoring to protect data and ensure compliance with security standards. Evaluating security features should consider specific requirements such as data sensitivity, regularity, compliance, access control policies, and security best practices. Let's talk about cost evaluation. In Apache Cassandra's open source nature eliminates direct licensing cost but may require investments in infrastructure support and optimization efforts, while MongoDB offers flexible pricing models with options for free community editions, subscription based enterprise editions, and managed cloud services catering to diverse budgetary and deployment needs. Now let's talk about key differences. Data models. In Apache Cassandra, columns-oriented data models suited for write-heavy workloads and real-time data, while MongoDB document-oriented data models offering flexibility for complex data structures and dynamic schemas. In scalability and performance, Apache Cassandra linear scalability with distributed architecture and optimized write performance, while MongoDB good overall performance with strong read capabilities and support for horizontal scaling. In consistency and availability, in Apache Cassandra, tunable consistency levels, eventual consistency by default, and high availability, while MongoDB strong consistency by default within replica sets operations for eventual consistency and readable failure mechanism. Finally, both Apache Cassandra and MongoDB offers distinct strengths and capabilities suited to different use cases, applications, requirements, and deployment scenarios. Making the right choice depends on understanding key differences, evaluating specific needs, and lightning database solutions with business objectives and technical considerations. For choosing the right NoSQL database depends on various factors such as your application requirement, scalability needs, data model preferences, consistency and availability trade-offs, security considerations, community support, and ecosystem capabilities. Here is a structured approach to help you make an informed decision. First, define your application requirements. Second, evaluate data model and schema flexibility. Third, scalability and performance requirements. Fourth, consistency and availability considerations. Fifth, security features. Sixth, community and support ecosystem. Seventh, cost consideration. Eighth, perform proof of concept POC and testing. Ninth, gather feedback and recommendations. 10th, make an informed decision. Thank you.